Most folks pull out a yellowing plant about 3 weeks too early. The plant isn't dead, it's hungry. And 9 times out of 10, the exact thing it needs is already sitting somewhere on your property. Not in a bag at the feed store, not on a shelf at the garden center, but already there. Some of it is in your kitchen trash. Some of it is growing wild at the edge of your field. Some of it comes from your animals. And one of these methods, I'll warn you up front, comes out of the bathroom. We'll get to that one. Here's what most gardening books won't tell you. The fertilizer industry in this country runs about $24 billion a year. Not one penny of that goes toward the methods on this list. You can't bottle a chicken coop. You can't patent an eggshell. And nobody at the garden store wants to mention the 2,000-year-old Japanese trick that's been shown in 65 peer-reviewed studies to raise crop yields by an average of 21%. What follows are 21 ways to bring a sick or fading plant back from the edge. Most cost nothing. Most work faster than anything in a plastic bottle. And every one of them is either backed by real research or by the kind of common sense farmers used for 2,000 years before the chemical fertilizer factory was even invented. Stick around. By the end of this video, you'll look at your trash, your weeds, your animals, and yes, even your bathroom, in a completely different light. Before we get into the methods, there's one thing most gardeners over 50 have been doing wrong for decades. We diagnose the wrong way. A plant that looks dead is almost never dead. The crispy brown leaves, those are gone. They won't come back. But the rest of the plant, usually fine, usually starving for one specific thing. And the whole trick is reading which thing. A few quick tells. Yellow leaves at the bottom, green at the top, that's nitrogen. The plant is robbing its older leaves to feed new growth. Yellow new leaves with green veins running through them. That's iron or sometimes magnesium. Stems still green when you scratch the bark with your thumbnail. Plant's alive. Don't pull it. Now here's the part that changes everything about how you fertilize. In the early 1950s at Michigan State University, a soil scientist named H.B. Tukey and a horticulturalist named Sylvan Witwer did something no one had ever done. They mixed radioactive phosphorus and potassium into a liquid spray, applied it to plant leaves, and tracked where it went using Geiger counters. What they found rewrote the rulebook on fertilizing. Nutrients sprayed on a leaf travel through the plant at roughly 1 ft per hour. Up to 65% of foliar nitrogen is absorbed inside of 25 minutes. A struggling tomato doesn't have to wait 2 weeks for soil bacteria to break down granular fertilizer. Sprayed on the leaves at sundown, it can be greener by morning. That is the secret behind every fast-acting method on this list. We're not feeding the soil first, we're feeding the plant directly through its leaves while building the soil up for the long haul. Some of these methods you'll know, some I guarantee you've never heard of, and 3 of them I'd bet money your grandfather used and your father forgot. Top 1. Wood vinegar, mokusaku. This one comes from Japan. They call it mokusaku. The Chinese have used it for 2,000 years. Korean farmers swear by it. The Japanese government registered it as an official soil improvement material in 1986, and almost no one in America has heard of it. Here's what it is. When you burn wood slowly in a low-oxygen environment, the same process that makes charcoal, a brown smoke, rises off the pile. If you cool that smoke down, it condenses into a dark, smoky liquid. That liquid is wood vinegar, also called pyrolinous acid. It's not just one chemical, it's over 200 of them. Acetic acid, methanol, phenols, trace minerals, a whole pharmacy of plant-active compounds captured straight out of the smoke. In 2025, 2 researchers named Liefeld and Waltz published a meta-review in the journal Agronomy. They pulled together 65 peer-reviewed studies covering 33 different crops, all of them using wood vinegar. The average yield increase across those studies was 21%. Plant biomass went up 25%, and it suppressed fungal disease at the same time. Now, you can't really make this at home unless you've got a charcoal kiln, so you buy it. The good stuff comes from bamboo or hardwood aged at least 3 to 6 months. A quart bottle costs less than a small bag of synthetic fertilizer. Here's the recipe and the dilution that matters most. For general use on tired or sick plants, you mix it 1 part wood vinegar to 200 parts water, about a teaspoon per gallon. You can spray it on leaves or pour it at the root zone. For seed soaking before planting, Dilute it the same way and soak the seeds for 24 hours. The mistake people make: going too strong. Anything above 1%, that's 1 part in 100, and the same product that boosted yields 21% will start killing weeds. Above 3%, it's a herbicide. Less is more here. If you've got tomatoes hit with early blight, peppers with leaf spot, or melons fighting fungus, this is the first liquid I'd reach for, and almost no one at the garden store will even know what it is. Top 2, aspirin, salicylic acid. This sounds like folklore. It's actually some of the best understood biology in modern plant science. Here's the story. In 1990, a team of scientists led by Daniel Klessig at the Waxman Institute published a paper in the journal Science. They showed that when a plant gets infected by a virus, fungus, or bacteria, the plant's first response is to produce a compound called salicylic acid. That salicylic acid then travels through the whole plant, switching on a system called systemic acquired resistance, basically the plant's broad-spectrum immune system. Now here's where it gets interesting. The active ingredient in aspirin is acetyl salicylic acid. Drop an aspirin in water, it breaks down into salicylic acid plus a tiny bit of acetic acid. Spray that on a tomato leaf, and you've just told the entire plant, trouble's coming. Get ready. The plant responds by producing what scientists call PR proteins, chitinases, glucanases, compounds that puncture fungal cell walls before fungus even shows up. The whole defense system gets primed and loaded, like a farmer locking up the chicken coop before the coyotes arrive. Now there's a story going around the internet about a master gardener in Rhode Island whose aspirin-sprayed tomatoes looked like they were on steroids. That part's anecdotal. The follow-up study didn't replicate the dramatic claim, but the underlying science, the immune priming part, is rock solid. Hundreds of peer-reviewed papers back it up. Here's the recipe. One regular 325 milligram aspirin tablet, uncoated, dissolved in 1 gallon of water. Add a single drop of dish soap so it sticks to the leaves. Spray every 2 to 3 weeks during the growing season. Best on tomatoes, peppers, potatoes, eggplants, the whole nightshade family, and brassicas like broccoli and cabbage. 2 mistakes I see people make. First, they use coated aspirin, which doesn't dissolve right. Use the cheap stuff. Second, they double or triple the dose thinking more is better. Is above 500 milliliters a gallon, the leaves start to burn. Stick with the 1 tablet. And here's the timing detail nobody tells you. This is a preventive treatment. You spray before the plant gets sick, not after. Once a fungus has its hooks in, the immune system can't undo the damage. But applied early, once a month from transplant on, the plant fights its own battles before you even see the first spot on a leaf. Top 3. Liquid seaweed extract. The next one is what real plant scientists call the most studied biostimulant on Earth. If you only ever buy one plant tonic in a bottle, this should be it. Liquid seaweed extract, usually made from a brown algae called Ascophyllum nodosum, harvested off the rocky coasts of Maine, Nova Scotia, and Iceland, has more peer-reviewed research behind it than any other natural plant input on the market. Universities in Canada, South Africa, and the US have spent the last 40 years pulling it apart in the lab. Here's what they found. Seaweed is loaded with natural plant hormones, cytokinins, the chemicals that tell a plant to grow new shoots, auxins, which signal root growth, gibberellins, which control stretching and flowering, plus betaines and amino acids that help a plant survive heat, cold, drought, and transplant shock. This isn't fertilizer in the NPK sense. It's a biological signal. You spray seaweed on a half-dead transplant, and you're telling the plant, hey, calm down, push out new roots, get back to work. A 2013 study at Dalhousie University in Nova Scotia showed that within 24 to 96 hours of a seaweed application, the plant's own hormone-producing genes start firing harder. A South African researcher named Van Staden showed that cabbage transplants dipped in seaweed had 33% more leaf weight 4 weeks later. Citrus growers in Florida use it to push trees through drought. Vineyard managers spray it after frost. You can buy commercial liquid kelp at any decent garden store, or if you live near the ocean, you can make it yourself. Collect storm-cast seaweed off the beach. Rinse it twice in fresh water to wash off the salt. Chop it, half fill a bucket. Cover with water. Let it ferment 2 to 3 weeks. Strain. Apply at 1 to 2 Oz per gallon of water for foliar spray. Once a week through the growing season. Early morning or evening, never midday. Here's the mistake almost everyone makes. They go too strong. There was a study at the University of Natal back in 1985 that found seaweed extract at 1 part in 100 actually slowed root growth on tomatoes. At 1 part in 600, the same product boosted root growth by 60%. More is not better. The plant hormones in seaweed are active at tiny concentrations, the same way a thimble of yeast can rise a whole loaf. Frostbitten transplants, drought-stressed peppers, a sad little tomato seedling that just got moved into the ground. This is the thing that wakes them up. Top 4, hydrogen peroxide. The next one isn't a fertilizer at all, it's an emergency rescue. Sometimes a plant isn't hungry, it's drowning, and the difference matters. You overwater a tomato in a clay pot, or a low spot in the garden holds water for 3 days after a heavy rain. The roots sit in stagnant water with no oxygen. Within a few days, fungi like Pythium and Phytophthora, which actually live in your soil all the time just waiting, multiply. They eat the roots from the inside out. The leaves wilt even when the soil is wet. By the time most gardeners notice, half the root system is mush. This is one of the few times when reaching for a chemical is the smart move, and it's a chemical you probably already own. Drugstore hydrogen peroxide. The brown bottle, the 3% kind, about $1 at any pharmacy. Here's the chemistry. Hydrogen peroxide is just water with one extra oxygen atom, H2O2 instead of H2O. When it hits soil, it breaks down into plain water and pure oxygen. That oxygen does two things at once. It oxidizes the rot fungi to death, and it reoxygenates the suffocated soil so healthy roots can breathe again. The recipe: 1 TBSP of 3% peroxide per cup of water for a soil drench. Pour it through the root zone until it runs out the bottom of the pot. For raised beds or in-ground plants, mix it in a watering can, same ratio, and saturate the soil around the base of the plant. Repeat every 3 to 4 days for 2 to 3 weeks until you see fresh white root tips on a careful pull test. Speed of result? If you catch it early, you'll see new white roots in 5 to 7 days. If the entire root ball is already black mush, the plant's gone. No miracles bringing it back. Now, 3 mistakes that ruin this. First, people buy 35% food-grade peroxide and use it straight. That'll burn the roots off the plant in 20 minutes. Use the 3% drugstore stuff. Second, right after using peroxide, people add compost tea or a microbial product thinking they're rebuilding the soil. Don't. Peroxide kills good microbes the same way it kills the bad ones. Wait at least a week before adding any biology back in. Third, don't mix peroxide with bleach, ever. That makes a gas that'll send you to the hospital. For a plant that's drowning, this is the rescue. Top 5. Diluted cow's milk. For a plant that's just hungry, well, the next one comes from a dairy farm. In 1999, a Brazilian agricultural scientist named Wagner Bediol got tired of watching organic farmers lose their squash crops to powdery mildew. He had a hunch. He ran an experiment. He sprayed zucchini plants with diluted cow's milk, 10% milk, 90% water, twice a week. He compared them to plants treated with synthetic fungicide and to plants treated with plain water. The water control plants, disease severity hit 56%. Synthetic fungicide brought it down to 9%. The milk spray, 10%. Statistically, the same as the chemical. 2-cent solution doing the same job as a $40 bottle. Bediol published his results in the journal Crop Protection. Australian researchers replicated the work on grapes. New Zealand wine country adopted it commercially. The Brazilian government started recommending it. Here's what's actually happening. When milk dries on a leaf in sunlight, the proteins and the riboflavin react with ultraviolet light to produce small amounts of oxygen radicals. Those radicals collapse the cell walls of fungal spores within hours. There's also a protein in milk called lactoferrin that ruptures fungal membranes directly. And the lactic acid bacteria sitting on the leaf surface compete with the fungus for nutrients. This isn't folk wisdom. It's a triple-action fungicide that costs you a splash of milk. The recipe: 1 part milk to 9 parts water. Skim, 2% whole doesn't matter. The fat isn't the active part. The protein is. spray to dripping on the upper leaf surfaces, the timing detail that makes or breaks it. You have to apply this on a sunny morning between sunup and noon. The UV light is what activates the chemistry. Spray it at dusk or under cloud cover and almost nothing happens. Reapply every 7 days during active infection. Reapply after rain. Best on cucumbers, squash, zucchini, melons, and pumpkins. The whole cucurbit family, plus grapes, roses, tomatoes, and any ornamental that gets that powdery white coating. The mistake people make is twofold. First, they reach for almond milk or oat milk because that's what's in their fridge now. Those don't work. There's no lactoferrin in plant milks. Use real dairy. Second, they go too concentrated, thinking 50% milk will work better. It doesn't. The leaf gets sticky, fat solids attract mold, and your sprayer clogs. Stick with 1 to 9. If you raise a few backyard chickens or a milk goat, you've got an unlimited supply of natural fungicide. The grocery store version works fine too. Top 6. Comfrey, Bocking 14. The next one is the British gardener's secret weapon, and it grows in any abandoned corner of your property. There's a plant most American gardeners walk right past. It's got fuzzy leaves about the size of a dinner plate, purple bell-shaped flowers, a taproot that goes down 5 or 6 feet. It's called comfrey. And in the 1950s, an Englishman named Lawrence D. Hills figured out it might be the single best plant fertilizer ever grown. Here's the story. Hills ran a research farm in a place called Bocking in Essex, England. He spent 20 years experimenting with a Russian variety of comfrey. Out of all the strains he tested, one stood out, strain number 14. It was sterile, so it wouldn't take over the garden. It was rust-resistant, and it had 2 to 3 times the potassium of farmyard manure. Today, every serious British gardener still calls it Bocking 14. Why does it work? That deep taproot. Comfrey sends roots straight down through subsoil where most garden plants can't reach. It mines minerals from down there: potassium, calcium, silicon, magnesium, and pulls them up into its leaves. You cut the leaves 4 or 5 times a season, and you've got the richest plant material in your whole garden. Now, most people make comfrey tea by soaking leaves in a bucket of water for 2 weeks. That works. It also smells like a dead body. There's a better way. The recipe Hills himself wrote about. Pack chopped comfrey leaves tightly into a bucket. Place a brick on top of the leaves. Drill a hole in the bottom of the bucket. Set the bucket up on bricks over a collection jar. No water added. Over 2 to 3 weeks, the leaves break down under their own weight. A dark, almost odorless concentrate drips out the bottom. Maybe a quart of liquid per 5-gallon bucket of leaves. That's your gold. Dilute it 15 to 1 with water. Pour it at the root zone of any flowering or fruiting plant: tomatoes, peppers, cucumbers, potatoes, dahlias, fruit trees, anything that needs to bloom or set fruit. The mistakes. First, don't put this on lettuce, spinach, or root crops. The high potassium causes them to bolt or grow weird. Second, only use Bocking 14, not the wild common comfrey, which spreads aggressively from seed, and you'll never get rid of it. Third, don't drink the tea. The plant contains compounds that damage the human liver. You can buy Bocking 14 root crowns from heirloom seed companies for a few dollars a piece. Plant them once. They'll feed your garden for 30 years. Top 7. Alfalfa pellets. The next one is a growth hormone you can buy at any farm store for about $3 a pound. This one is the rose grower's secret. Most flower clubs in this country have known about it for 50 years. Almost no vegetable gardener has heard of it. Walk into any farm supply store, buy a 50 lb bag of alfalfa pellets, the kind people feed to rabbits and horses. $20 or so. Take it home. You now have by weight the cheapest plant growth regulator in agriculture. Here's the science behind it. In 1977, a researcher named Stanley Reese at Michigan State University was studying alfalfa. He pulled out a compound he hadn't expected to find: a 30-carbon alcohol called triacontanol. He published the discovery in the journal Science. Then he ran the next experiment. He sprayed dilute triacontanol on rice seedlings. He measured them 40 minutes later. 40 minutes. The rice plants had measurably more weight, more chlorophyll, and more nitrogen content than the control. That's not slow soil chemistry. That's a switch flipping inside the plant. Triaconanol works at parts per billion concentrations. The plant uses it as a signal to ramp up photosynthesis, accelerate nutrient uptake, and boost chlorophyll production. Today, commercial farmers in Asia spray triacontanol on millions of acres of rice and wheat. But here's the thing. You don't need a fancy spray. You just need alfalfa. The recipe. 1 cup of alfalfa meal or pellets in a 5-gallon bucket of water. Stir it once a day for 2 to 3 days. It will smell like a barn. That's normal. Pour about a gallon of the tea around the base of any rose bush, peony, daylily, or iris. A smaller plant gets less. Once a month during the growing season, the American Rose Society has been recommending this for decades. Rose growers report doubled bloom counts. Iris growers say the same. Now here's where the vegetable gardeners come in. Triaconanol works on tomatoes, peppers, brassicas, and most perennials too. The amino acids and B vitamins in alfalfa are a bonus on top. 2 mistakes. First, don't try to spray full-strength alfalfa tea on leaves. It'll burn them. If you want a foliar version, cut it down to a 1/4 cup of meal and 5 gallons of water. Second, don't use this on flowering perennials in late fall. It pushes out tender new growth that frost will kill. Stop a month before your first frost date. $20 buys you 2 years of fertilizer for a 1/4-acre rose garden, and you can feed any leftover meal to the rabbits. Top 8 fish hydrolysate. Speaking of which, the next method is one almost nobody knows the truth about, including the people who raise the animals. The Pilgrims didn't survive their first winter because of pumpkins. They survived because a Wampanoag man named Tisquantum, most people remember him as Squanto, taught them to bury a fish under each hill of corn. That wasn't superstition. That was the original liquid fertilizer. When you bury fish in the ground, the soil bacteria break the fish protein down into amino acids. And amino acids are nitrogen the plant can drink. No mineralization required. No 2-week wait. The roots pull it up almost as soon as it dissolves. Modern commercial fish hydrolysate is the same idea. Made faster, whole fish, ground up, treated with enzymes that break the proteins down cold. The result is a thick brown liquid that smells exactly the way you'd expect. NPK around 411 to 522, plus 16 amino acids, fish oils, and natural chelates that help the plant absorb minerals. Now, there's a difference between fish hydrolysate and the cheaper fish emulsion at most garden stores. Emulsion is steam cooked. The heat denatures the proteins and burns off the oils. You're left with a fertilizer that has the nitrogen, but lost most of the magic. Hydrolysate is enzyme processed cold. It keeps everything. If you live near a coast or a lake, you can make your own. Korean natural farming has a recipe called fish amino acid. The University of Hawaii published the protocol. Here's the short version. Take fish scraps, heads, guts, frames, especially oily fish like mackerel or sardines. Layer them 1-to-1 by weight with brown sugar in a clay or plastic bucket. Cover with cloth, never a sealed lid, or the gas will explode the container. The fish liquefy in 2 or 3 days. The mixture is usable in 7 to 10 days, fully cured in 2 months. The finished liquid smells weirdly sweet like soy sauce. The brown sugar feeds bacteria that suppress the rotten fish smell. To apply, 1 TSP of finished fish liquid per gallon of water. Yes, a teaspoon. This stuff is concentrated. Pour at the root zone or spray on leaves once a week during the vegetative growth stage. Stop once your plant starts setting fruit, or the excess nitrogen will give you giant leaves and small tomatoes. The mistake, people make the fish ferment in a sealed bucket. The pressure builds up and you end up with fish guts on the ceiling of your shed. Cloth cover, always. If you don't fish, a quart of commercial fish hydrolysate runs about $15. Lasts a backyard gardener 2 seasons. Top 9. Rabbit manure. The next one comes out of a hutch, and it's the only manure on earth you can use straight from the animal. Most manure has to be aged. Chicken manure is so hot with ammonia, you put it on a tomato plant fresh from the coop, and you'll burn the roots off in 2 days. Horse manure has weed seeds. Cow manure has to compost 6 months minimum. Rabbit manure is different. It's the one and only common manure on earth that you can apply straight from the animal. Fresh, the same day, with no aging, no composting, no waiting. Old-time farmers called it cold manure. The nitrogen is bound up in a slow-release form that doesn't burn roots. The pellets are dry, almost odorless, and naturally crumble into the soil. The numbers. Rabbit manure runs about 2 to 2 and 1-2% nitrogen, 1 and 1-2 to 2 and 1-2% phosphorus, and roughly 1% potassium. Compare that to cow manure at 1-2% across the board. Rabbit pellets carry roughly 4 times more nitrogen than cow patties. If you raise meat rabbits or pet rabbits, you've already got a gold mine sitting under those cages. To use it dry, just sprinkle pellets directly around the base of plants and water it in. They'll release nutrients over 4 to 6 weeks. To make tea, and this is the part that earns the chapter. Take a couple cups of pellets, drop them in a pillowcase or burlap sack, tie the top, drop the sack into a 5-gallon bucket of water, let it sit for 2 to 3 days, stirring once a day. Pull the sack out, dilute the tea down to the color of weak coffee, about 1 part tea to 10 parts water. Pour at the root zone. Speed, visible greening in 3 to 5 days. No burn, no smell. Best on tomatoes, peppers, leafy greens, brassicas, anything in the vegetable garden, houseplants too. Diluted half strength. Now the mistake, and I see this on homestead forums every spring, people use rabbit manure from rabbits on medications. If your rabbit is on a dewormer, antibiotics, or any medication, skip the manure for a couple of weeks afterward. Those compounds can pass through. The other thing, some folks raise rabbits over a worm bin, which is brilliant. The worms turn the manure into the most concentrated vermicompost you'll ever see. Top 10, wood ash. We'll come back to vermicompost in a few minutes, but first, there's a method old enough that the Romans wrote about it, and powerful enough that you can ruin your soil if you use it wrong. Every wood stove in this country produces, at the end of winter, a 5-gallon bucket of one of the most powerful natural fertilizers on Earth. Most people just throw it on the driveway to melt ice. Hardwood from a clean wood fire is roughly 25% calcium carbonate, 4 to 10% potassium, and 1 to 2% phosphorus plus trace boron, copper, manganese, magnesium. It's calcium and potassium in a form so soluble, it'll change your soil chemistry within a month, for better or for worse. Used right, wood ash will sweeten an acidic soil, push potassium into fruiting plants, and add calcium that strengthens stems and fruit. Used wrong, it will kill your blueberry bushes and ruin a potato crop. Let me give you the rules. Old-time farmers knew them. Most modern gardeners don't. Rule 1, test your soil pH first, or at least know what you're growing. Wood ash raises pH. If your soil is already neutral or alkaline, pH 7 or above, wood ash will push it past where most vegetables can grow. If your soil is acidic, pH under 6 and 1 over 2, wood ash is a gift. Rule 2, the application rate, about 20 per 1,000 square feet per year. That's 1 full 5-gallon bucket spread over the area of a small backyard garden. More than that, you start tipping the chemistry too far. Rule 3, the plants that love it, brassicas, broccoli, cabbage, kale, cauliflower, asparagus, beets, tomatoes, stone fruits, lawn grass. Any of these on slightly acidic soil will perk up within weeks. Rule 4, the plants that hate it, blueberries, rhododendrons, azaleas, hydrangeas if you want them blue, camellias, conifers, all acid lovers. Wood ash kills the acidic soil they need. Rule 5, and this one most people don't know, don't put wood ash on potatoes. There's a soil microbe called Streptomyces scabies that causes potato scab, those rough corky patches on the skin. Wood ash favors that organism. You'll get a beautiful crop of ugly potatoes. The other mistake, people burn glossy magazines, plywood, painted lumber, charcoal briquettes, and then put the ash on their food crops. Don't. Heavy metals, formaldehyde. Burn only clean firewood, no treated lumber, no paper with colored ink. Apply ash in the fall or early spring. Spread it thin on a windless day. Rake it into the top inch or 2 of soil. Water it in. Used right, that bucket of ash from your wood stove is worth $50 of soil amendment. Top 11, borax boron. The next one is the opposite of wood ash. It's a single nutrient used in a single dose for a single problem. This one is short, specific, and it'll save your brassica crop. If you've ever cut into a broccoli stem and found a hollow brown core running through the middle, that wasn't bad seed. That wasn't poor watering. That was boron deficiency. Boron is one of the strangest nutrients in plant biology. The plant only needs it in tiny amounts, fractions of a part per million, but it can't move once it's in the leaf. So when the new growth at the top of the plant runs out of boron, the whole growing tip suffers. Hollow stems in broccoli, brown hardened turnips and rutabagas, brittle deformed cauliflower curds, strawberries that come out misshapen. Most American garden soils, especially east of the Mississippi where rainfall leaches it out, are mildly boron deficient. Most gardeners never test for it, so they just lose part of their brassica crop every year and chalk it up to bad luck. The fix is sitting on a shelf at the laundry aisle of any grocery store. 20 Mule Team Borax, $5 lasts 10 years. The recipe, 1 TBSP of borax dissolved in 1 gallon of warm water. Stir until clear. Spray that gallon evenly over a 100 square foot section of brassica or root crop bed 1 time per season. That's it. I want to repeat that. 1 TBSP per gallon per 100 square feet once a year maximum. Boron has the narrowest deficiency to toxicity window of any plant nutrient on Earth. Below half a part per million, the plant starves. Above 4 parts per million, the plant dies. You're aiming for a tiny window in between. Now the absolute hard rule: beans, peas, soybeans, and lentils do not put borax anywhere near them. They are extremely sensitive to boron. A dose that would help your broccoli will kill your green beans dead. Keep the borax bed at least 10 FT or from any legumes. The crops that actually want this treatment: broccoli, cauliflower, cabbage, Brussels sprouts, beets, Swiss chard, turnips, rutabaga, strawberries, apples, celery. If you've been losing half your broccoli to hollow stem, this single application, once in early spring before transplanting, will give you a solid crop of tight, dense, perfect heads. It's the difference between farm stand broccoli and grocery store broccoli. Top 12. Calcium acetate, eggshells, and vinegar. The next 4 methods all come from one farmer in South Korea who developed a complete farming system in the 1960s and quietly trained over 18,000 farmers across 30 countries. In the 1960s, a farmer named Cho Han-kyu in Suwon, South Korea, traveled to Japan to study under 3 old farmers who had spent their lives developing a system of completely natural farming inputs. Cho came home, refined what he learned, and turned it into a complete method called Korean natural farming. Over the next 60 years, he trained over 18,000 farmers in more than 30 countries. The University of Hawaii formalized his recipes into agricultural extension publications. Cho passed away in 2025 at the age of 90. His first recipe is the easiest. It's also the one that fixes the single most common problem in any tomato garden in America: blossom end rot. That black sunken patch on the bottom of an otherwise beautiful tomato? Most people are told blossom end rot is a calcium deficiency. That's only half right. The actual problem is that calcium in the soil isn't moving into the developing fruit fast enough, usually because of irregular watering. But adding more soluble calcium to the system gives the plant a buffer. Cho's solution is brilliant chemistry. You take eggshells, which are pure calcium carbonate, and you dissolve them in vinegar, which is acetic acid. The reaction produces calcium acetate, a calcium compound that is fully water-soluble and immediately plant available. You've taken the calcium that was locked up in eggshell rock and turned it into liquid the plant can drink. The recipe. Step 1. Roast a handful of eggshells in a dry cast iron skillet for 30 minutes until they turn light brown. The roasting burns off the membrane, which would otherwise rot. Step 2. Crush the roasted shells coarsely. Step 3. In a glass jar, add 1 part shells to 10 parts vinegar by volume. Brown rice vinegar is the original recipe. White vinegar works too. Step 4. Cover the jar with a piece of cloth secured with a rubber band. Never a sealed lid. The reaction releases carbon dioxide gas. Pressure will explode glass. Step 5. Wait 7 to 20 days. When the bubbling stops, the reaction is complete. Strain off the shells. To use, dilute 1 TSP of the calcium acetate liquid into 1 gallon of water. Spray on leaves or pour at the root zone. Apply just before flowering and during fruit set. Honest note, this will not cure blossom end rot that's already on a fruit. Once a tomato has the black patch, that fruit is finished. But every fruit that develops afterward, those will be clean. So apply this preventatively, not reactively. Cost-free. Every household throws away the shells in a little vinegar. Top 13 Fermented Plant Juice, FPJ. The next Korean natural farming recipe is wilder. This one is going to sound strange the first time you hear it. Stick with me. Cho Han-kyu observed that the fastest growing parts of any plant, the new shoots, the growing tips, contain higher concentrations of plant hormones, enzymes, and energy-rich compounds than any other part. The plant sends its richest molecules to the places where it's pushing out new growth. If you could capture those compounds, ferment them, and feed them to other plants, you'd be giving them a hormonal head start. That's fermented plant juice, FPJ for short. The recipe. Step 1. Just before sunrise, ideally 2 or 3 days after a rain, walk out to a patch of vigorous, fast-growing plants. Mugwort, bamboo shoots, comfrey, stinging nettle, purslane, sweet potato vine. Pick the youngest growing tips, whatever's pushing new growth hardest. Step 2. And this is critical, do not wash them. The wild yeasts and lactic acid bacteria living on the leaf surface are what drive the fermentation. Washing kills them. Step 3. Cut the plant material into 2 to 3 inch pieces, weigh it. Step 4. Mix 3 parts plant material to 1 part raw brown sugar, not white sugar, not molasses, crude brown sugar, the kind sold in Asian groceries as panela or jaggery. Step 5. Pack the mixture 2/3 full into a glass jar or clay pot. Cover with paper or breathable cloth. Never seal it. Step 6. Wait 5 to 10 days at room temperature. The sugar pulls water and chlorophyll out of the leaves through osmosis. Wild lactobacillus and yeasts ferment the result. You end up with a thick, fragrant, dark green liquid sitting on the bottom of the jar. Strain off the liquid. That's your FPJ. It will keep in a cool, dark place for months. To apply, mix 1 tablespoon of FPJ into 10 ml of water, roughly 1/1000 dilution. Spray on leaves or pour at the root zone. Once a week, always early morning or evening, never midday sun. What's in it? Plant hormones from the young growing tips, live lactic acid bacteria and yeasts, natural sugars, free amino acids, trace minerals from the species you used. What it does, it signals other plants to wake up, push new growth, and resist stress. It's not fertilizer in the NPK sense. It's a biological message. Honest note, no university lab has run a full controlled trial on FPJ that I can find. The mechanism is plausible. Korean and Hawaiian farmers swear by it. Try it on a couple of plants alongside a control before committing your whole garden. Top 14. Lactic acid bacteria serum, labs. The next Korean natural farming recipe is the one that turned me into a believer. You know what's living on the rinds of cabbages, on the surface of grape skins, on every piece of fruit you bring home from the garden? Lactobacillus, the same family of bacteria that makes yogurt, sauerkraut, kimchi, and sourdough. Cho Han-kyu figured out a way to capture them off your kitchen and grow them by the billions in a quart jar. The result is the most powerful microbial inoculant most American gardeners have never heard of. Here's the recipe, 2 stages. Stage 1, capture the wild lactobacillus. Take a cup of uncooked rice, rinse it once in dechlorinated water, pour off that first rinse, then rinse a second time, harder. The water comes out cloudy, milky white. That second rinse is what you want. Pour the rice rinse into a quart jar. Fill the jar 2/3 full, cover with a paper towel. Set it in a dark cabinet at room temperature for 3 to 5 days. The smell will turn slightly sour. That's the wild lactobacillus multiplying. Stage 2, grow them on milk. Skim off the thin film on top. Pour the middle layer into a clean half-gallon jar. Add 10 parts whole milk to 1 part of that rice starter. Whole milk works best, not ultra-pasteurized. Cover the jar with paper. Wait 3 to 7 days at room temperature. The mixture separates. White curds rise to the top. A clear yellowish liquid sinks to the bottom. That bottom liquid is your finished lactic acid bacteria serum. It contains roughly 100 million to 1 billion live lactobacillus per milliliter. Strain off the curds. Feed them to chickens or compost them. Bottle the serum. Refrigerate it for up to a year or mix it 1 to 1 with brown sugar to keep it shelf stable. To apply, 3 to 4 of a teaspoon per gallon of water. Spray on leaves, pour at the root zone, or add to your compost pile. What it does. Lactic acid bacteria suppress fungal pathogens by lowering local pH and producing antibacterial compounds called bacteriocins. They solubilize phosphate locked up in the soil. They eliminate odor in compost and animal pens. They've been documented in lab studies to inhibit pythium, botrytis, and phytophthora. The agricultural research is thin compared to the food and animal husbandry research, where this is rock solid. But farmers in Hawaii, Korea, and the Philippines have been using it for 50 years. A gallon of milk and a cup of rice will make you enough serum for a season's worth of treatments. Try working out that math against the price of any commercial probiotic on the garden store shelf. Top 15. Whey. The next one's similar, but it comes off the cheese block. If you've ever made yogurt, mozzarella, ricotta, or any cheese at home, you've poured gallons of liquid down the drain. That liquid is whey, and whey, it turns out, is almost identical to the lactic acid bacteria serum we just made. When you add a starter culture to milk, the lactobacillus eats the milk sugars and produces lactic acid. The acid curdles the proteins. You strain off the solid curds for cheese. What's left in the strainer is whey, water, residual milk sugar, minerals, and live lactobacillus by the billions. If you live on a homestead with milk goats, milk sheep, or a dairy cow, you've got an unlimited supply of this stuff. Even if you just make yogurt at home from store-bought milk, the whey is the same product. 2 ways to use it. First way, same as milk spray for powdery mildew. 1 part whey to 9 parts water. Spray on a sunny morning. Wagner Bertiol's lab in Brazil confirmed in 2008 that whey at this concentration reduced cucumber powdery mildew by 70 to 94%. Same as the milk study from earlier. Second way, use it as a microbial inoculant. Dilute it 1 TSP per gallon of water and pour at the root zone. The lactobacillus do the same work as the Korean labs we just made, suppressing fungal pathogens, freeing up phosphate, balancing the soil microbiome. 2 free uses out of 1 byproduct. Now, a word on what kind of whey works. Whey from yogurt or unpasteurized cheese is full of live bacteria. That's the good stuff. Whey from heavily pasteurized commercial cheese is dead. The minerals are still there, but the biological action is gone. The mistake people make, they store whey in a sealed plastic bottle on the counter for 2 weeks and then wonder why the cap blows off when they open it. Lactobacillus keep fermenting at room temperature. Refrigerate fresh whey within a few hours, or better, use it within 48 hours. If you make a half gallon of yogurt every 2 weeks, you produce a quart of whey. That's enough to spray powdery mildew on a quarter-acre cucumber patch all summer for free from a byproduct. A homesteader friend of mine pours her goat cheese, whey directly onto the bases of her tomato plants every Friday afternoon during the season. Says her tomatoes haven't had a serious fungal problem in 8 years. Top 16, vermicompost. T. The next one is a method that turns kitchen scraps not into compost, but into a whole army of underground workers who do the actual fertilizing for you. There's a man named Norman Aronson who spent the last 20 years at Ohio State University, then the University of Hawaii, doing something most agricultural researchers won't touch. He ran field trials on worm compost. Trial after trial, his team published the same finding. Vermicompost, the dark crumbly castings that come out the back end of a red wiggler worm, outperformed regular compost on yield, growth, and disease suppression. Tomatoes, peppers, strawberries, lettuce, marigolds, pak choi, even the houseplants in the lab. The active ingredients aren't just the nutrients. They're humic acids, fulvic acids, and a specific community of plant growth promoting bacteria that worms cultivate in their guts. Arancon showed in 2003 that humic acids alone, isolated from worm castings, produced measurable growth response on plants at concentrations of just 250 to 500 parts per million. You can buy worm castings at most garden centers, 20 bucks a bag. Or, and this is where it gets fun, you can keep a 5-gallon worm bin in your garage, feed it your kitchen scraps, and produce a steady stream of castings for free. Either way, here's how you turn solid castings into liquid worm tea. The recipe. Take 1 cup of worm castings, drop it into a mesh bag. An old sock works fine. Tie the top, suspend it in a 5-gallon bucket of dechlorinated water. Add 1 TSP of unsulfured molasses to feed the bacteria. Now the part that matters, aerate. Run an aquarium air pump through a stone in the bottom of the bucket for 24 hours. The air is what multiplies the beneficial bacteria. Without aeration, you just get muddy water. Use it within 4 hours of pulling the pump. The microbes start dying off as soon as the oxygen runs out. To apply, dilute 1.5 with fresh water. Pour at the root zone of any plant or strain through cheesecloth and use as a foliar spray. Once every 2 weeks during the growing season. The honest part, the peer-reviewed evidence on vermicompost tea is thinner than the evidence on solid vermicompost. Top dressing a plant with a 1/4 cup of dry castings gives you more consistent results than the tea form. So if you have to pick one, pick the solid stuff. The tea is a bonus when you want fast root zone delivery. The other thing, this needs to be drilled in. Compost teas brewed with molasses can grow harmful bacteria like salmonella if your compost source isn't clean. Use the tea on ornamentals or pour it at the root zone of food crops. Don't spray it on leafy greens you'll eat raw. Top 17, Bokashi leachate. The next one is its anaerobic cousin, and the bucket smells worse. But the math is interesting. Most people in this country have never heard of bokashi. In Japan and Korea, it's been the standard way to handle kitchen waste for 50 years. Here's how it works. You take a 5-gallon bucket with a tight-fitting lid and a spigot at the bottom. You sprinkle a layer of inoculated bran that's been mixed with effective microorganisms. The EM blend developed by Dr. Teruo Higa in Okinawa in the 1980s. You add a layer of food scraps, even meat and dairy, which a regular compost pile can't handle. More bran, more scraps, pack it down, seal the lid. Inside the sealed bucket, the EM microbes ferment the food anaerobically. 2 weeks later, you've got pickled food scraps you can bury in the garden, where they break down rapidly into compost. But here's the part most people miss. As the food ferments, liquid drips out of the mass and collects at the bottom of the bucket. You drain it through the spigot every few days. That liquid is bokashi leachate. The chemistry. Bokashi leachate has very low nitrogen, but high potassium and phosphorus, plus a massive concentration of beneficial microbes. The pH runs around 3 and 1/2 to 4 and 1/2, strongly acidic. Now, I'm going to be honest. A Swedish study found bokashi tea grew bok choy slower than commercial fertilizer in some soils. The leachate is too low in nitrogen to be a complete plant food on its own, so treat it as a microbial inoculant, not a fertilizer. The recipe. You don't make bokashi leachate, it makes itself. You just need to drain the bucket spigot every few days and collect what comes out to apply on plants. Dilute heavily, 1 part leachate to 100 parts water. Pour at the root zone once every 2 weeks. Use the diluted liquid within 8 hours. The microbes die off without their food source. Now here's the killer use of bokashi leachate that almost nobody mentions. Pour the undiluted leachate down your kitchen sink, your shower drain, your toilet, or your septic tank. The lactic acid bacteria and the low pH break down sludge, eliminate odors, and balance the microbiome of a septic system. People who've used it for years swear they haven't had to pump their tank as often. If you don't have a bokashi bin, the system runs about 50 bucks for the bucket and 20 for a year's worth of inoculated bran. You handle every food scrap your house produces, including bones, dairy, citrus rinds that a regular compost pile rejects, and the byproduct goes on to the garden. Top 18, nettle tea. The next one is the British weed tea tradition, and this one comes off your fence line. There's a weed growing along almost every fence line in the country. It bites you when you brush past it. Most people consider it a pest. The French call it ortie, and they ferment it in a bucket and call the result purin d'ortie, nettle slurry. They've used it as fertilizer for centuries. Stinging nettle, Urtica dioica, has one of the highest free amino acid concentrations of any wild plant. Asparagine and arginine dominate, both nitrogen-rich, plus iron, magnesium, calcium, copper, zinc, and silica that the plant pulls up through its deep root system. Estimated NPK around 5 on 11. A 2021 study published in the journal Sustainability tested fermented nettle extract on green beans. The result, nettle extract matched commercial urea for stem height, significantly raised iron levels in the leaves, modest yield difference. That's a free fertilizer matching a synthetic from a weed. The recipe, step 1, wear gloves. Stinging nettle stings. Step 2, cut about a pound of fresh nettles, stems and leaves both. Don't pull them up by the roots. Leave the roots in the ground, and they'll regrow within a few weeks. Step 3, stuff the nettles into a 5-gallon bucket. Fill it 3/4 full to allow for foam. Top with rainwater or dechlorinated tap water. Step 4, cover the bucket loosely. Set it in a corner of the yard somewhere downwind of the house because the smell during fermentation is rough. Step 5, stir every couple of days. After 10 to 14 days, when the smell goes from sharp to earthy, strain off the liquid into a clean bucket. Compost the spent leaves. To apply, dilute 1 part nettle tea to 10 parts water for soil, 1 to 20 for foliar spray. Pour or spray on vegetative stage plants once every 2 weeks. What works best on it? Leafy greens, brassicas, tomatoes during their early growth phase, anything that needs to push out leaves. What to skip? Don't use this on legumes, which fix their own nitrogen. Don't use it on root crops, which respond poorly to high nitrogen. Don't use it once tomatoes start setting fruit, or you'll get giant plants with few tomatoes. The mistake almost everyone makes. They make it once, smell it, decide it's not worth it, and never make it again. Yes, it stinks, so put the bucket 50 FT from the house, cover it, move on. The fact that it stinks is also the proof that the bacteria are doing their job. For $0 and the cost of a pair of gloves, the weeds along your fence line can fertilize your entire vegetable garden. Top 19, aerated compost tea. The next one is going to make you rethink everything you knew about compost. This one's been hyped on every gardening podcast for the last 20 years. I'm going to give it to you straight. In the 1990s, a microbiologist named Elaine Ingham at Oregon State University started promoting actively aerated compost tea. The pitch was simple. Take good compost, steep it in water, bubble air through it for 24 hours. The bacteria multiply into the millions per milliliter. Apply that microbial soup to your plants. Watch the results. It made sense in theory, and for some people on some soils, it works. Here's the problem. The peer-reviewed evidence is messy. A 2014 study by researchers at Bartlett Tree Experts and Morton Arboretum ran a 5-year trial on urban trees. They compared aerated compost tea against wood chip mulch and against compost top dressing. The wood chip mulch increased tree biomass by 170% over the control. The compost top dressing went up 82%. The compost tea, no significant effect. A 2002 review by Shurel and Mahaffey found that compost teas vary so wildly batch to batch, you can't guarantee the same result twice. A 2004 study showed that compost teas brewed with molasses, if your compost source was contaminated, could grow salmonella from 1 colony per milliliter to over 350,000 in 72 hours. Here's the honest take. Compost tea can be useful, but solid compost on the soil consistently outperforms tea applications. If you have to pick one, pick the solid stuff. If you do brew tea, here's how to do it right. The recipe: 5 gallons of dechlorinated water, 1 to 2 cups of high-quality finished compost in a mesh bag, 1 to 2 tablespoons of unsulfured molasses, 1 TSP of liquid kelp, 1 TSP of fish hydrolysate. Aerate continuously with a strong aquarium pump for 24 to 48 hours at room temperature. Use it within 4 hours of pulling the pump. After that, microbes start dying off. The tea goes anaerobic, and anaerobic compost tea grows the wrong things. The hard rule: don't foliar spray manure-based compost tea on edible crops. The USDA's National Organic Program prohibits it. Pour it at the root zone or spray it only on ornamentals. The other rule, quality compost in, quality tea out. If you brew tea from contaminated compost, you grow contamination. Use compost that's been hot composted to at least 130 for at least 3 days or known clean source. I'd rather see most gardeners spend their effort top dressing solid compost on their beds. Tea is a bonus, not a foundation. Top 20 biochar. The next method goes the other direction. It's the slowest one on this list. Takes a year to fully kick in. And it's been working in the Amazon rainforest for 1,000 years. In the 1500s, the Spanish conquistadors traveled up the Amazon River. They reported finding patches of soil unlike anything in the surrounding rainforest. Black, deep, fertile. The natives called it terra preta, black earth. The Spaniards thought it was natural. It wasn't. 500 years later, soil scientists figured out that pre-Columbian Amazonian peoples, for at least 1,000 years before European contact, had been intentionally building those soils. They mixed pottery shards, fish bones, manure, and crucially, charcoal, the leftovers from low-temperature fire pits. Today, those terra preta patches still grow crops at 3 times the productivity of the surrounding jungle. The active ingredient is biochar, charcoal made by burning wood at low temperatures with very little oxygen. The result is pure carbon with a microscopic surface area like a sponge. A single gram of biochar has roughly the surface area of a tennis court. That sponge does 2 things in soil. First, it holds water. Terra preta soils retain moisture better than any other tropical soil ever measured. Second, it holds nutrients and microbes. Bacteria colonize the pore spaces. Fertilizers don't leach away. The carbon stays in the soil for thousands of years. Now there's a catch, and almost no online article mentions it. Fresh biochar is a sponge with nothing in it. If you put fresh biochar straight into your soil, it sucks up the nutrients in the soil for the first year, often reducing yields. You need to charge it first. Here's how. Take fresh biochar. You can buy it or burn your own from clean hardwood scraps. Soak it for 48 hours in something biological. Compost tea, diluted urine, fish hydrolysate, worm casting tea. The biochar absorbs the nutrients and microbes. Or, slower method, mix fresh biochar 50-50 with finished compost and keep it moist for 2 weeks. The compost charges the char. To apply, mix charged biochar into the top 6 in of soil at no more than 5 to 10% of soil volume. More than that, you tip the carbon to nitrogen ratio too far. Speed of result, you won't see a big effect the first season. By year 2, you'll notice the soil holds moisture longer. By year 3, the bed is producing visibly bigger plants on less fertilizer. By year 10, that bed is more productive than the day you built it. This isn't a quick fix. It's a 1,000-year investment that pays compounding returns. Cornell University's Johannes Lehmann is the leading biochar researcher in the world. He's documented the same effect over and over. It's real. Top 21, human urine. And the last method on this list, it's going to surprise you the most because it comes out of the bathroom. I told you we'd get here. I'm going to lay out the science straight, then you decide. The human body excretes nitrogen, phosphorus, and potassium every day. About 80% of the nitrogen, 50% of the phosphorus, and 60% of the potassium that ends up in our waste comes out in urine, not solids. Fresh, healthy urine is sterile when it leaves the body, roughly 95% water. The rest is urea, a small amount of salt, and trace minerals. The NPK of human urine averages about 11, 1,2, and 1,2, comparable to commercial liquid lawn fertilizers like Uramila Y1. In Brattleboro, Vermont, an organization called the Rich Earth Institute has been running the only community-scale urine recycling program in the United States since 2012. They collect about 12,000 gallons a year from 200 donors. They've run multi-year field trials with Fairwinds Farm, hay yields with urine fertilizer matched yields with synthetic fertilizer. They published their results in peer-reviewed journals. They also collaborated with the University of Michigan and University at Buffalo on a study about pharmaceutical residues. The conclusion, you would have to eat a pound of urine-fertilized lettuce every day for 2,000 years to ingest 1 dose worth of acetaminophen. about 4 million salads to match the caffeine in 1 cup of coffee. In Switzerland, a research institute called EWAG developed the world's first government-approved urine-based commercial fertilizer in 2018. They sell it under the brand name Orin. The Romans collected urine in public urinals and taxed its sale because tanners used it. Amish and Mennonite farmers have used chamber lye for centuries. In Asia, every farming culture older than 4,000 years recycles human urine. The recipe: collect fresh urine in a clean jug. Dilute 1 part urine to 10 parts water. For seedlings, dilute 1 part to 20. To apply, pour at the root zone. Never on leaves, never on edible parts you'll eat raw within 4 months. Best on hay, sweet corn, leafy greens, brassicas, hemp, lawn grass, and cut flowers. For raw-eaten crops like lettuce or strawberries, World Health Organization guidelines say, store the urine sealed in a closed container for 6 months at room temperature first. The urea breaks down to ammonia, which sterilizes any potential pathogens. For crops cooked before eating, 1 month of storage is enough. The mistakes: applying it undiluted, which causes salt burn, using it on potted plants, where salts can't leach out, and ignoring it just because the source feels strange. This is one of the cheapest, most concentrated, most studied fertilizers in agricultural history. You produce it free every day, and most people in this country flush it down the drain. So that's 21 ways to bring a sick plant back from the edge. If you remember nothing else from this video, remember this: the fertilizer industry in this country wasn't built because chemical fertilizer works better. It was built because chemical fertilizer can be patented, packaged, and shipped in a truck. You can't put a chicken coop on a pallet. You can't sell shareholders an eggshell. There's no quarterly earnings report for a comfrey patch. Almost everything on this list: the wood vinegar, the seaweed, the fish hydrolysate, the comfrey, the ash, the manure, the urine, was used by farmers for 2,000 years before the Haber-Bosch ammonia plant fired up in 1913. Fritz Haber and Karl Bosch fed half the world's population with synthetic nitrogen, and that's a real achievement. But they also taught a generation of farmers to feed the plant while starving the soil. The dead zones in the Gulf of Mexico, the collapsed soil structure across the Great Plains, the loss of microbiology under most American crop fields, all downstream of that decision. The good news is that for a backyard gardener, a small farmer, a homesteader, none of that matters. You don't need to feed half the world. You just need to feed your family and maybe sell a few crates of tomatoes at the farmer's market. And for that work, the old methods don't just compete with chemical fertilizer. They beat it. A foliar spray of seaweed extract will outpace a granular synthetic on a transplant. A milk spray will match the best fungicide on a powdery mildew infestation. A rabbit manure tea will green up a tomato plant faster than the blue crystal stuff. And every one of these methods builds the soil at the same time it feeds the plant, which the synthetic never does. A few practical takeaways before we wrap up. Don't try to use all 21 of these at once. Pick 3 or 4 that fit your situation and your animals. If you keep chickens, fish hydrolysate. If you brew kombucha or make yogurt, weigh in labs. If you've got an oak in the yard, wood ash from the stove. If you live near the coast, seaweed. The system that works is the one that fits your kitchen, your land, and your habits. Apply foliar sprays in the early morning or evening. Never midday sun. Dilute everything. More is rarely better. Test on a few plants before committing the whole garden. And the last thing, pay attention. The plant will tell you what it needs. Older leaves yellow first. That's nitrogen. Newer leaves yellow with green veins. Iron. Black bottom on the tomato. Calcium and water. Wilted with wet soil. Root rot. Get the peroxide out. The kitchen, the bathroom, the wood pile, the chicken coop, the worm bin, the fence line, the seashore. Every one of them is a free fertilizer factory. The gardener who knows how to work all of them never buys a bag of fertilizer again. Happy gardening. If these ancient secrets and natural methods have changed the way you look at the weeds in your yard or the scraps in your kitchen, please subscribe and like the channel. We are dedicated to uncovering the powerful history and science that the modern industry has tried to keep hidden. Let's cultivate a more fertile future together. The next vault of gardening wisdom will be opened very soon.